Bismillahirrahmanirrahim. Hello students, I am Thaiba Nazir and I am here to teach you mathematics of grade 9. Here we are studying chapter 1 matrices and determinants. Now we are solving exercise 1.2. So let's get started with question number 1. First question is, from the following matrices identify unit matrix, row matrix, column matrix and null matrix. First we memorize all these definitions and then we can solve it easily. First is unit matrix. In unit matrix all the entries are equal to 1. So here in question number 1, D part is a unit matrix because in D the diagonal entries are equal to 1. So next is row matrix. A matrix called row matrix if it has only one row. So here B is a row matrix because B has only one row. Next is a column matrix. In column matrix has only one column. So here C and F has only one column. Then both are column matrices. And in null matrices all the entries is equal to 0. So here in matrix A and E all entries are 0. Therefore these are null matrices. Next is question number 2. From the following matrices identify square matrix, rectangular matrix, row matrix, column matrix, identity matrix and null matrix. Here are some questions. So in first part, -8, 2, 7, 12, 0 and 4. This is a matrix and it contains 2 rows and 3 columns. So we know that when number of rows not equal to number of column, then the matrix will be rectangular matrix. So here number of rows not equal to number of column, so this matrix will be rectangular matrix. In next part 3, 0, 1, this is also a rectangular matrix because it has 3 rows and only one column, so it's a rectangular matrix. And it's also a column matrix because it contains only one column. So next part is 6 minus 4, 3 minus 2. This is a square matrix because in square matrix we know that the number of rows equal to number of columns. Here in matrix 2 rows and 2 columns, so this is a square matrix. And in next part 1, 0, 0, 1, this is also a square matrix because it contains 2 rows and 2 columns. And it's also an identity matrix because its diagonal entries are equal to 1, so this is a identity matrix. So next question is 5, 1, 2, 3, 4, 5, 6. It contains 3 rows and 2 columns, so this is also a rectangular matrix. And in question 6, 3, 10, minus 1, it contains 1 row and 3 columns, so number of rows not equal to number of columns, so this is a rectangular matrix. And it also a row matrix because it contains only one row. So in next question the entries are 1, 0, 0. This is also a rectangular matrix and a column matrix because a number of rows not equal to number of column, that's why this is a rectangular matrix. And it also contains one column, so this is a column matrix also. So in next question, number of rows equal to number of column. So in this matrix 3 rows and 3 columns, so these are equal, so this is a square matrix. And in next question, number of rows not equal to number of columns because in this question 3 rows and 2 columns, so this is a rectangular matrix. And it's also a null matrix because all the entries are equal to 0, so this is also a null matrix. Next is question number 3. From the following matrices identify diagonal matrix, scalar matrix and unit or identity matrix. Here some questions are given. So first question, A is equal to 4, 0, 0, 4. It's a 2 cross 2 matrix and its diagonal entries are non-zero. So we know that when diagonal entries are non-zero, and non-diagonal entries are equal to 0, then the matrix will be diagonal matrix. So it's a diagonal matrix, but it's also a scalar matrix, because we know that in scalar matrix diagonal entries must be similar. So here 4 4 are same, so it's also a scalar matrix. Next, B is equal to 2 0 0 minus 1. It's also a 2 cross 2 matrix, so their diagonal entries are non-zero, so it's also a diagonal matrix. Next question, C is equal to 1 0 0 1. It's also a diagonal matrix and as well as unit or identity matrix, because its diagonal entries are equal to 1, so it's a unit matrix. So next, D is equal to 3 0 0 0. It's also a diagonal matrix because their diagonal entries are non-zero. Here one entry is 0, not the both. If both entries are 0, then this matrix will become a null matrix, but here only one entry is 0, so this is a diagonal matrix. Next, E is equal to 5 minus 3, which is equal to 2, and 1 plus 1 is also 2, so 2 and 2, this is diagonal matrix as well as scalar matrix because its diagonal entries are similar and non-zero. Next is question number 4. Find negative of matrices A, B, C, D and E. We know that negative matrix is obtained by changing the signs of all entries. So negative sign change into positive and positive sign change into negative, because it's obtained by changing the signs of all entries. So in question number A is equal to 1 0 minus 1, we change their sign. 1 change into minus 1 0 as it is, and minus 1 change into 1, this will become a negative of a matrix A. Similarly, B, we change 3 into minus 3, minus 1 change into 1, 2 change into minus 2, 1 change into minus 1, this will become negative of B. Similarly, C is equal to 2 6 3 2, 2 change into minus 2, 6 change into minus 6, 3 change into minus 3, 2 change into minus 2, so this will also become minus C, negative of C. So in next D part, D is equal to minus 3 2 minus 4 5, so minus 3 change into 2, 2 change into minus 2, minus 4 change into 4, and 5 change into minus 5, so this will become a negative D. And similarly, E is equal to 1 minus 5 2 3, 1 change into minus 1, minus 5 change into 5, 2 change into minus 2, and 3 change into minus 3, this will become a negative of E. Next is question number 5. Find the transpose of each of the following matrices. Here are some matrices are given and we can find the transpose of all these matrices. So we know that transpose of a matrix is obtained by interchanging the rows into columns or columns into rows. So here A is equal to 0 1 minus 2. This is a matrix of 3 cross 1 order. So A transpose is equal to change the rows into column. So when we change the rows into column, then this matrix will be 0 1 minus 2, rows change into columns. So next, B is equal to 5 1 minus 6. So B transpose is equal to change the rows into column, so it will become 5 1 minus 6, rows change into columns. So similarly in C transpose is equal to 1 2 2 minus 1 3 0, rows change into columns. So in D 2 3 0 5, 2 3 row first row and change into first column, so D transpose is equal to 2 3 0 5. Similarly in E 2 3 minus 4 5, so rows change into column, 2 3 change into column, and minus 4 5 change into second column, so E transpose is equal to 2 3 minus 4 and 5. Similarly, F is equal to 1 2 3 4 and its transpose is equal to rows in change into column, then F transpose is equal to 1 2 3 4. Next, question number 6. Verify that A is equal to 1 2 0 1, it's a 2 cross 2 matrix, and B is equal to 1 1 2 0, it's also a 2 cross 2 matrix. Then we find A transpose, again transpose is equal to A. Similarly, B transpose, then take again its transpose, which will be equal to B. So we can easily find these two parts. Let's get started with first one. So first, A is equal to 1 2 0 1 and we take its transpose. So A transpose is equal to 1 2 0 1, changing rows into column. So again taking its transpose, then it will become 1 2 0 1, it's equal to the capital A. So A transpose and its transpose equal to A. Next, in second part, take B is equal to 1 2 1 0, take its transpose. So B transpose is equal to 1 1 2 0, change the rows into column. Next, again taking its transpose, changing rows into column, so it will become 1 1 2 0, so it's also equal to B. So B transpose and taking its transpose equal to B.